say, okay, this device is now registered. And we're not really comfortable with that model. So we have a much looser notion of ownership. So we're willing to be lax about what is considered yours, which in some cases could be used to say, you and I could say, oh, we're just one, right? Okay, that will happen. But what we do is we limit how much damage we can cause by doing that. So if I cannot create, and one important aspect is how big my network of devices can be. Because if we didn't have a limit on the number of devices, then, and because we're kind of protocol independent, we could do this over Nutella, right?
Right.
And now we would have a domain with 1 million devices. So what we do is we limit the size rather than having a very hard notion of ownership.
What if in that model you offered more value for people who registered, but still allowed people who didn't register to use the device?
That's a possibility that's enabled by the technology. And in fact, one of the things we do is we say, okay, we're going to allow consumers to come home from Circuit City, power up their device, and it will just join all the other devices. But we're going to limit how many devices can join in that manner. And the minute you say there's going to be a limit, no matter what that limit is, somebody will say, okay, I want 1 more, or I want 10 more. I'm Bill Gates, I have 500 devices. What do you mean I can only have 5? So what we've done in our protocol is we have an exception mechanism where if you want to go beyond this number of devices that can join without contacting anyone else, then the price you pay is you need to contact this central server. So because we have these two models, now we can basically have a slider to say, how big this initial, local authorization can be.
What number are you thinking of?
For abstract presentations,
I don't think it makes any difference.
For abstract presentations, I always use the number 5 because I can always use one hand. I think in reality, it's going to be more complicated than that. We're probably going to have different numbers for different kinds of devices. So for example, if you have, say, XCP-enabled speakers, and you have a surround sound system, then you've already used all, more than the 5 that you have. So we may allow, I don't know, 20 speakers, but only 5 TVs. I'm not sure exactly how what the number is going to be, and my prediction is that it's probably going to be based on media. Ideally, it would be just one number that everyone agrees to. That would be the simplest scenario. I just don't think that's realistic.
Unless IBM's changed a lot, it's usually their role to create the technology and let the market fill in the numbers. Mm-hmm. So the IBM won't decide how many you get. They'll just say there'll be this structure which will allow you to limit it to so many, and then the industry, our friends at the RIAA, and other people will define how big that number is.
Yeah. So let's see. Let's do the protocol because that's a kind of dynamic part. And so basically, the model is such that we have different devices. There's some sort of connectivity. Each device, as I said before, will have a key, and these keys are going to be different for each device. Some of the devices may have more may have storage capability. Some may not. For example, this could be just a pure client, a pure streaming client, for example. So some devices will have storage, and the storage doesn't really need to be tightly bound necessarily. And some devices may have extra processing power represented by those gears here. So the idea is that we're going to distribute parts of the system throughout these devices. Now, let's assume that we start with 2 devices already being part of the cluster and a new device comes along, which is this guy over here. The first thing it does is it broadcasts a message saying who's there, and it provides a URL so that people can contact the new device. Now, it gets 2 responses, one from each of the existing devices saying, I'm here. This is point-to-point using the original URL. Now, what this guy wants to do is it wants to join the cluster. So it's going to send, will you authorize me request. But in that request, it needs to prove to these guys that it's a good device. And so it needs to prove that it's compliant, because we don't want clones joining our network. So what it does is it computes a MAC, a message authentication code, based on the key management block that this guy has. Now, let's think about that for a second, because this is the key part. If this guy has a key management block, and that key management block is revoking this device, then this guy will not be able to compute the right code, the right MAC. So it accomplishes the idea that it's not going to allow non-compliant devices into the cluster.
Excuse me, I thought the key management block came on the device like it came on your DVD, not your DVD player. Your DVD player had 1 key.
Right. So in this model, because it's binding to the user or not, it's a different model. All the devices in this cluster, in this particular cluster, are going to agree on a common KMB. Because things are no longer bound to a particular piece of media. This KMB is now floating. It's a file on the network. So if we go back,
So how
I
does,
indicate that the KMB is stored by the devices.
so how does your local is that the device over the device on the left find out that the device on the right has been blackballed?
So it finds out when this guy tries to join
Yeah.
and is not able to process this guy.
Well, how does that guy get the information he's not supposed to process it?
Sorry?
How does the one on my left, the authorizer, it's just another device in the same household, right? How is that informed, that somebody in Hollywood at the RIAA has blackballed the client?
Well, because it has a key management block.
Yeah.
And that key management block
How's it get updated?
came from, how is it updated?
Oh, it's not updated, it was just at the time that that was manufactured, it was blackballed.
Well,
And it
all of
doesn't
the above.
necessarily
and
had
it
a
doesn't know
URL.
it doesn't know what's subsequently blackballed.
All of the
The previous
above.
site had a
It
URL.
probably comes with a KMB, probably shipped with an initial KMB to kind of bootstrap the process.
Yeah.
And then, for example, when new devices join, you're getting ahead of the protocol,
Oh.
but when new devices join, they're going to say, okay, here's a new KMB. Should we collectively update our notion of KMB? Or perhaps one of these devices is, say, a set-top box, and it has a feed from the outside, and it's getting KMB updates.
Yeah.
So basically, the system, this particular cluster, is going to be updating its key management block over time.
Yeah.
Yes, you had a question?
Yeah, is there a master device in the cluster? Is there one that's sort
No.
of policing it, or is it completely distributed?
It's completely distributed. In fact, you could have multiple authorizers on the network. And what the protocol guarantees is that everyone ends up with the same notion of, how to compute the key to protect the content.
Okay, I don't think this would work, because you got an old authorizer, and it doesn't know the latest blackball list. A client comes along, it's manufactured later, it then gets blackballed, but the old authorizer isn't going to know that, and it's going to accept the client anyway, and the client is going to join anyway.
Right. So there's always going to be a delay between when a device gets compromised,
Yeah.
when it gets identified, it gets blacklisted, and then this notion of the blacklist gets distributed to
This
the world.
authorizer never gets the distribution of the new blacklist.
Yeah, it does, because there are external connections to the cluster. If there are no external connections,
Yeah, I would.
then, no, if there are no external connections, then you're not getting any new content, right?
Oh.
If you are getting new content, the new content will come protected with a new KMB, for example.
Mm.
So at that point, either you refuse to process all new KMBs, or you update the notion of revocation. So the idea really here is to distribute this notion of revocation, this revocation list, without requiring central connectivity.
What if you make a mistake and blackball a good client?
Right.
So you, don't worry, so you.
You make a phone call to support.
Well, in practice, revoking a device is not something that you would do lightly. So before you do that, you would probably be very careful. Now, having said that, errors do happen, and I think it'll be covered by the warranty of the device manufacturer.
Can a revocation be undone?
No.
No.
I mean, technically it can. You could say, okay, from now on, this KMB, for the month of February, we use this KMB, and we shouldn't have revoked all these devices. But that creates problems in the local notion of the revocation list. So the assumption is that revocation lists can only grow. They can never shrink. Yeah.
The KMD is universal among geography and population, but not extensible in time. It doesn't stay the same over time, but it stays the same. One single KMD.
No, there are lots of KMBs in the system. Thousands, millions of KMBs in the system. And over time, you would say generate KMBs that revoke more devices, right? As more devices get compromised, KMBs will have a bigger revocation list. But my cluster and your cluster may have a totally different KMB.
Or they may not.
Or they may not. Yeah.
All right, when you talk about the key management block of, I take it we're talking about a authorized copy of anything, or a digital copy, and you've got a key on this copy, and then you find out this is not a valid copy. You're going to corrupt the. How do you corrupt the? I don't understand how you corrupt the copy. First of all, am I on the wrong trail here?
You don't understand how you corrupt what?
I mean,
sorry.
you've got a. You're trying to prevent something from being copied, and you've got a set of keys that are authorized keys to install a device, right? Okay, you detect that